Welcome back. So today we are going to learn PERT, that is Project Evaluation Review Technique. This is also part of network analysis in operation research. Now let us understand the theory first and let us solve the problem. Now Program Evaluation Review Technique PERT is a probabilistic method where the activity times are represented by probability distribution. The PERT was developed to determine time estimate for the activities. Expected time of an activity is in some real life situations is difficult. Finding the exact activity time is difficult. This distribution of activity time is based on three different estimates, that is optimistic time estimate, most likely, and pessimistic. Optimistic means, let's say your project is to build a house. In that, one of the activities you have to do the flooring or the tiles work. To complete the tiles work activity, let's say the project, that activity takes 10 days optimistically, means that's the smallest time taken to complete an activity. If everything goes correctly according to your plan, that is optimistic. What is most likely? Most likely is normally there will be some delays. So on an average, it might take 15 days, 5 days more than optimistic, maybe average time. So usually based on the experience, you'll say that okay, even if everything goes right, there will be some delays. Like sometimes labors don't turn up, or sometimes some things happen. So 15 days. They are 10 and 15. Now this is denoted by Tm or M. This is denoted by T0 or A. The pessimistic time is, let's say everything what you have planned goes wrong. The worst time taken to complete a project is 25 days. Now that is 25 here. So when you ask a laborer what is optimistic, most likely, and pessimistic, with this formula you can calculate the time estimate for the activity. For tiles work, you can put 10 days plus 4 into 15 days plus 25 days divided by 6 you get, and you will get to do a flooring work how much time estimate you will get. That is the weighted average you will get. Once you get that, you can calculate the variance for that activity. Variance is sigma square is equal to T plus T0 divided by 6 raised to whole square. Now what is T0, Tm or M or Tp? It is already given here. Optimistic time is denoted by T0 or A. Most likely time estimate is denoted by Tm or M. Pessimistic time is estimated by Tp or P. The expected length duration denoted by Te and the specified date Ts. The main objective of the analysis of the PERT is to find the completion date of a particular event through specified date given. Let's say the due date given for a particular project to complete is 50 days, and you put the CPM and you find out the expected completion date is 36 days. So 50 minus 36 divided by variance is given here. You will get a figure, a number, that is D. That is the expected length duration. Once you get that, the probability according to the normal distribution, you can find out what is the chances that it will complete. Let's say you will get that it takes 78% chances that it will complete within a particular time, or 85% chances that the project will be completed in 50 days. Like that. In how many days? If it is 50 days, how many chances, that is, you will get in answer in percentages, and you can solve it. Now quickly you have understood the theory first. Now let's go and solve the problem firsthand to understand what it is. Now here is the first example. The following table shows the jobs of a network along with their time estimates. Now this is the job. Now the activities, what are there? Now following estimates are given. Optimistic, most likely, and pessimistic timings are given. Now what they've asked is, they've asked you to draw the project network and find the probability of the project completing in 40 days. The overall project, what is the chances that the project completes within 40 days? That is the question. Now to find the answer to this question, let us go and put the network for this particular problem first, and then probably we will be able to understand how to go about the other things here. Now let me just put the graph, the graphical representation here for this particular problem. Okay, The first one is 1 to 2. So I will try and use as minimal area as possible. So 1 to 2, then you have 1 to 6. So 1 to 6, then you have 2 to 3. Okay. Then you have 2 to 4. Then you have 3 to 5. Then you have 4 to 5. Okay. Then you have 6 to 7. Then you have 5 to 8. Then you have 7 to 8. Okay. Now, as per the jobs what they're given, I have put the network here. Now, only next thing what we need to do is, for activity 1 to 2, what is the time estimate? For 1 to 6, what is the time estimate? In CPM problem, this was already given. Now here in this problem, it is not given. So what we need to do is, we need to calculate using the formula. So what is the formula what we have here? Here, I will just give an example. I will not solve the entire this thing, and I will just tell you how to get the time estimates for each of the things. So activity, that this is the time estimate. TE is equal to T0 plus 4TM plus TP divided by 6 is the answer. Then the sigma square is equal to TP minus T0 divided by 6 whole square is your sigma square. Okay, you need to have a table like this. Now first activity is 1 to 2. When you get the first activity, now you need to see what is T0 or A. T0 or A is 1 plus 4TM, that is 4M. 4M is 4 into 7 plus, that is TP or B, that is 13 divided by 6. So you got this clear? T0 or A plus 4TM, 4 into 7 plus 13 TP divided by 6. If you do this, you will get that for the first activity, the TE is 7. So you got this. As 7. So from 1 to 2, the time estimate is 7. Okay. For the second activity, that is 1 to 6. From 1 to 6, the time estimate you want to find out. So first one is T0, that is 2 plus 4 into 5. 5 is your TM plus 14. 14 is your TP divided by 6. How much you will get? That is 6. So from 1 to 6, you are getting this as 6. So similarly, you should start doing for all other activities. Similarly, sigma square you need to find out. Now here, for the first one, it is 13 plus 1 divided by 6 whole square. It's better if you have a scientific calculator with you, so that calculation will be easy. That is 4. For the second one, sorry, it is not 13 plus 4, that is 13 minus 4, that is 13 minus 1, that is 12 divided by 6. 12 divided by 6 is 2. 2 square is 4. Similarly here, it is 14 minus 2 divided by 6 whole square. Now that is equal to 4 again. So in this way, you will calculate the sigma square. So now I will write directly what are the time estimates you will get for each of the activity and the variances. So for each of the activity, for one is 1 to 2, it is 7 and it is 4. For 1 to 6, you are getting it as 6 and 4. For 2 to 3, you are getting it as 14 and 16. From 2 to 4, it is 5 and 1. From 3 to 5, it is 11 and 4. From 4 to 5, it is 7 and 4. And 6 to 7, it is 11 and 16. Then 5 to 8, it is 4 and 1. And it is 7 to 8. 7 to 8, it is 18 and 16. So these are the time estimates. What basically you should be getting it here. Now, once you get the time estimates, you will write the time estimates in front of each of the activity. From 1 to 2, it is 7. 1 to 6, it is 6. From 2 to 3, it is 14. And 2 to 4, it is 5. Then 3 to 5, it is 11. Then 4 to 5, it is 7. 6 to 7, it is 11. 5 to 8 is 4. And 7 to 8 is 18. So once you do this, you are expected to do the forward passing and the backward passing. Okay. So once you are doing the forward passing and the backward passing, it starts with 0 here. So from 0 to this 1 to 2, you will get it as 0 plus 7 is 7. Here you will get 0 plus 6 is 6. Now 6 plus 11 is 17. Right? Now here from 2 to 3, now 14 plus 7 is 21. Now from here, if you see 7 plus 5 is 12. Now 12 plus 7 is 19 and 21 plus 11 is 32. Which one you should be going for? Whichever is maximum, you need to take that. 19 or 11, you should take 32. So what I'm doing here is I'm taking here it as 32. Then 32 plus 4 is 36. 17 plus 8, 17 plus 18 is 35. So which one is greater? 36 is greater. So what I will be doing here is It is 36. So, so basically, if you have a calculator with you, it will be good when you're solving these problems. Okay. Now, 36 minus 4. When you're going now, this is the forward passing what you've done. Now doing the backward passing. So forward passing, you're taking the maximum amount. When you're coming backwards, you need to take the minimum amount. 36 minus 4 is 32. Now 36 minus 18 will give you 18 here. Alright. So 18 minus 11 will give you 7 here. Okay. Now when you're coming backwards this side, okay, it is 36 here. Okay. 32 minus 11. 32 minus 11 will give you 21 here. Now 32 minus 7 will give you 25. Here it is 25. This is 25. Okay. Now 25 minus 5 is 20. Then 21 minus 14 is 7. Now if you come this way it is 7. If you come this way it is 20. Which one you should take? It is a backward passing, you should take 7. So I have written 7 here. Okay. Now this 7 minus 7 is 0. The 7 minus 6 is 1. Which one you should take? It's a backward passing. You need to take the minimal. So it is 0 here. So in this way, what you have done is you have found the start time and the end time for each of the events. So now if you see, the critical path is 0, 0, 7, 7, 21, 21, 32, 32 and 36, 36. So we have got the critical path 1 to 2, 2 to 3, 3 to 5 and 5 to 8. So what is the critical path here? You have to find out the critical path which you have done it. That is 1 to 2, 2 to 3, 3 to 5 and 5 to 8 is your critical path. Once you have found out the critical path, you need to find out how many days, what is the project completion time. The total project completion time is 36. Okay. Anyway, you have got 36 here. Before writing that, let us write the variance. That is, okay, the project length variance. The project length variance is how much? The present length variance is 1 to 2. 1 to 2 is how much? 4. So 4 variance is equal to sigma square is equal to 4 plus 2 to 3. 2 to 3 16. Then 3 to 5. 3 to 5 is 4. Then 5 to 8. 5 to 8 is 1. If you calculate this, the project length variance is, it is 25. Sigma square is 25. So what will be sigma? Sigma is equal to 5. Square root of sigma square. That is 25. That is 5. So is it clear? So project length variance is, variance is 25 and sigma is 5. Now what's the next thing? We don't need this anymore, so we'll take this off. because all we wanted is time estimate, which we have put here. Sigma square, we have got the project length variance. So we don't need this anymore. So I'm taking this off. Alright. So once we have got this project length variance, what is the total time duration for the project to complete? The total project duration is total project duration is 36 days, correct? Now that is time estimate is 36 days. Now what was the scheduled time or the standard time estimate, standard time what they were giving us? That is 40 days. That is TS, means they are asking us, can you complete, what is the possibility that you will complete the project in 40 days? But when we estimated it, we got it as 36 days. Okay. Now once we get this, we have to see the probability that project will complete in 40 days is given by. Okay. Now we have to write it. The probability that project is completed in 40 days is given by, the probability is given by P of Z less than or equal to D. Okay, where D is equal to TS minus TE divided by sigma. TS minus TE. Can you see that it is E? I will write it again. E. So TS is 40 minus estimated time is 36 divided by sigma, project length standard deviation is 5. Basically that was root of, in the formula it was given by root of sigma square. Root of sigma square, how much sigma square you got as 25? So 25 root is 5. That's why we are writing it as 5 here. In the formula you can see that root of square root of sigma square. So it's nothing but sigma. Right? So you're writing it as 5. So once you calculate this, it is 4 divided by 5. That will be equal to 0.8. Once you get this, okay, once you get this, you need to see the table, the normal distribution table. I don't need the graph anymore or the network path anymore, so I'm going to take this off. So I'll take this off as well. So you got this as D. D is 0.8. Now this is not the final answer. Now you need to find out under the normal distribution curve, normal curve area, the area under, you need to find the probability of completion of D. Now area under the normal curve for the region Z is less than or equal to 0.8. Z less than Z or equal to D. It is that Z is less than or equal to D. You have to find the probability, like how it is to be completed here. Now we can say that P is such that Pz is less than or equal to 0.8. That is, here what you will be getting is 0.5. Now before I write anything, now you need to see the table here. Now table here is, now before I write anything here, let me explain how the normal distribution curve works. Now the normal distribution curve, you can see the normal distribution curve something like this. Okay. Now if you divide the normal distribution curve into a half like this, it is symmetrical. If you fold it, exactly it folds in the similar way. So it is exactly symmetrical on each of the sides. Now the probability of this entire normal distribution curve is equal to 1. Now the left hand side it is 0.5 and the right hand side it is 0.5. Now if you see the table of 0.0, if you see the table value for 0.8, okay, now what you will be getting is this half of the table value is given. Now when you get this half of the value, you need to add it with this one. You know, they'll be giving only this part. Okay, you need to add with this one. What is the remaining part? You need to leave it. How I'll show you right now. So now probability of normal standard variable z is less than or equal to 0.8 is given by is equal to 0.5 plus phi of 0.8. Now what you need to do is you need to see the table. Now let us go back here to see the table value. Now once we go back here, you can see the table value here. Here is the normal distribution table, it's gone here. Now here, you can see that as entering the table of the areas under entire normal curve between normal variate z is equal to 0 and positive value of z, areas for negative value of z are obtained by symmetry. Symmetry in the sense half is given here, half you can get by adding it as by 0.5. Now this is the first decimal, this is the second decimal. The first decimal is 0.8. We don't have a second decimal, so 0.80. So it is 0.80. You will see here. If it was 0.81, then you should see 0.8, and here it is 0.01. So here it is only 0.8. That means 0.80. So it is 0.2881. Now this is only the half. The other half you will get it at the symmetry. So where is it? So it is 0.8 is 2881. This is how you need to see the table. And now come back to the problem. Now here this value we have got. This value is 0.2881. Now this one is 0.5. Out of this 0.5, it is 0.2881. So you are covering entire this area of the curve. This is 0.5 plus this area, which is 0.2881. So 0.5, that's why you have taken this 0.5 here, and phi of 0.8, that is equal to 0.5 plus, now phi of 0.8 is 0.2881, 0.2881. If you add this, you get a 0.7881. If you convert this decimal into percentage, you will get it as 78.81%. Now what is this 78.81%? 78.81%, there are chances that the project gets completed within the scheduled given time, that is 40 days. So there are 78% chances. There are 78% chances that the project gets completed within 40 days. Now you have to put a conclusion box. If the project is performed 100 times under same conditions, there will be 78.81 occasions for this job to be completed within 40 days. Means 78% more chances that it gets completed within 40 days time. This is how you need to solve the Pert problems. Pert. You can draw this somewhere else here on the right side. You can continue writing the problem which I have written on the right side here. You can continue here and write the percentage. And you have to put the graph to get the full marks on the other end of the page here. Okay, so this is the problem what you solved. We'll see the next problem in the next video. Thank you.